Welcome back. This is one of the first videos, if not the first video, in our new unit on covalent bonding. In this video, I just want to introduce to you the nomenclature system for covalent molecules or molecular compounds, which is a little bit more accurate. There's some similarities to ionic, but then again, there are also some definite differences. So let's go through some naming rules. First of all, these are molecular compounds, one of the two types of covalent. Therefore, these compounds are only going to be made up of nonmetals only, and it's possible you could see a metalloid. And that's the way we're going to do it this year. Look for nonmetals. Now, once you establish it as a covalent compound, here are the naming rules. You're going to identify and name each element present. And by the way, these are binary. So there will only be two elements. You'll give it a first name and a last name, just like we did with ionic. The good news is that the suffix will always be IDE. So every covalent name will end in IDE. The unique thing about the covalent nomenclature system is the use of the prefix. What the prefix does is tell how many. So it will reflect on the subscript from the chemical formula. And we will have a prefix for each atom present, except the first word will never start with mono. That's it. That's the only exception. Every other time you should start with a prefix. The second word will always have a prefix. The first word will always have a prefix except mono. I can't give you a good reason why that is, but it's just the way it is. So let's look at those prefixes. 1 through 4 are kind of arbitrary. In the covalent system, for 1, we're going to use mono. 2 is di. Many of you are going to try to use bi from time to time, but don't do that. We're going to use di. 3 is pretty easy, tri. 4 is unusual, tetra, as in a tetrahedron. You have heard of tetrahedrons in geometry, so bring that familiarity with 4 now to chemistry. So tetra is 4. Beginning at 5, we have our normal geometric prefixes. Penta is 5, hexa for 6, hepta is 7. Now, many students, some of you are going to get caught in this, you want to use septa for 7. I don't know why, but every year there's a large percentage of students who do that. Maybe it's because you watch Game of Thrones, I don't know. But 7 is hepta. 8 is octa, as in octagons, and then nona for 9. That's easy. It sounds like the number 9. And then deca. So those are our prefixes. Let's scroll down now, and let's do a little practicing. Our first example is N2O3. So that's nitrogen and oxygen. I have 2 nitrogens, so we're going to begin this with dinitrogen. No suffixes on the first word. Dinitrogen, we have 3 oxygens, so this is going to be tri. And then oxygen needs to end in IDE, so oxide. Dinitrogen trioxide. All right, number 2, we have sulfur and oxygen. Now there's only 1 sulfur, but remember the exception said never start the first word with mono. So this is just going to be sulfur. And we have 2 oxygens, so it's dioxide. Similar thing happening here, number 3. We have xenon, no mono, and then 6 fluorine. So this is going to be hexafluoride. Number 4, back to 2 nitrogens. We've seen that already. Dinitrogen. 5 phosphorus atoms. 5 gets a penta. phosphide. Okay, number 5, we have selenium and sulfur. So the first word here would just be selenium. We will not start it with mono. And then disulfide because there are 2. Number 6, we have a phosphorus. And then 3 hydrogens, hydrogen ends in ide, it's hydride. All right, and the last 2, we have 2 phosphorus, so that we will start with diphosphorus. Pentaoxide for the 5 oxygens. And then finally, number 8, 1 carbon, so we just say carbon. 4 is tetrafluoride. I bet that you're thinking this is pretty easy. And most students would agree with you, it's pretty easy. Now let's compare it back with ionic naming that we did and have done recently in the past. So for ionic compound, they're both binary. We have 2 names, and for ionic, it's cation, anion. That's your first name and last name. And for these, we either have monatomic ions or we have polyatomic ions. So if it's a polyatomic ion, we will never change the name. And if it's a cation, we don't really change it. But if it's a monatomic anion, we add the suffix IDE. And then the thing that you probably hated the most about ionic was knowing when to use the Roman numeral. And throughout the year, that will continue to be the bugaboo. So let's quickly review ionic with some examples here. Then we'll do a few more covalent, and then you'll have your homework practice. So number 1, K is my cation. That is potassium. Don't do anything to that name. And then SO4, you recognize that as polyatomic. We have memorized that to be sulfate. We don't change a thing. Potassium sulfate. Number 2, I have a transition metal, so I could have a Roman numeral. So I've got to figure out what my charge is. Hydroxide is -1. There's 2 of them, so copper is going to be +2. So this is going to be copper 2 hydroxide. Remember doing that? Number 3, we have 2 elements, so we don't have to worry about any polyatomics here. Calcium and then phosphide. Number 4, I do have a polyatomic. NH4 is my cation here, and we call that ammonium. And then fluoride. And then number 5, we have another element that is not a transition metal, but it's a lower P metal that can have multiple charges. And in this case, this is lead 4. Lead 4 nitrate. So hopefully you remember doing that. Now once again, let's go back and compare it with our covalent. We just learned using the prefixes. Carbon dioxide. Very similar. If that were ionic, we would have just said maybe carbon oxide. But since it's covalent, that prefix tells us that we're dealing with something different. ClO2. Now here's one where a lot of you would miss for a couple of reasons. A lot of you would say dichloride, but it's not. It's the first word, so it's dichlorine. And then 7 oxygens is not sept, it's hept oxide. So dichlorine heptoxide. Number 3, nitrogen with no prefix, triiodide. with 2 I's, which is weird. Number 4, remember what 4's prefix is? It is tetra. So tetraphosphorus decasulfide. And then we have a metalloid here, diarsenic. We have only 1 oxygen, so monoxide. And using our grammar rules, it becomes just monoxide. All right, you got some on the following page here to practice on your own. You have to choose if it's ionic or covalent, and then apply the appropriate naming system. If you have any questions, make sure to come by and ask.